Patty Simpson with Simpson Math. In this video, we're going to work some theoretical or classical probability problems. So first, let's just start with the traditional balls in an urn or marbles in a jar type of problem, where we're going to pour out a certain number of balls and we'll just see what the probability is we get different colored balls. So let's start with just drawing one ball from the urn. Now, if I'm going to draw just one ball from the urn, I want to know what's the probability that we get, what's the probability we draw a red from the urn. Now, I want to encourage you when you're working these theoretical or classical probability problems to stop first before you think numbers and just think words. How would I go about drawing just one marble, drawing a red from the urn? Well, in this situation, since it's just one marble, I would have to draw a red. I'm going to write down that word. I know on this one it seems a little silly, but as we make these harder and harder, it's going to be really important that we're able to put it into words first and before we talk numbers. Then once we've kind of got our mind wrapped around what we're doing and we have the word down, then we can stop and think about the probability of that specific thing. So what is the probability I get a red from this jar? Well, remember when we're talking about the probability of something, in the denominator we have the total number of ways we could draw something. Well, the total number of ways are the total number of balls in here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 balls in the urn. So that total number comes down on the bottom. Then on top, it's the number of things that we're looking for of that event. So in this case, it's the number of reds in the urn. So there are 3 reds. So the probability that we draw a red with one draw is 3 out of 10. Let's do another. Instead of drawing a red, how about we try to draw a green or a black? So what's the probability we draw a blue or a black marble from the jar? So again, what I want to do is encourage you to first put it into words. So before we begin, I'm just going to draw out one marble, and when I'm done, I want a blue or a black. Well, if I'm going to get a blue or a black in my one draw, I could draw a blue. So maybe I draw a blue. Or maybe I didn't draw blue in my one draw. Maybe I could draw a black. So those are the 2 ways I could do it. So I'm going to say a blue, or I could draw a black. Again, I'm going to really encourage you to put it into words first. And be sure and use these conjunctions like or and, because that's going to help us when we're figuring out the probability. So here, what is the probability? Now that I've got it written down into words, now we can find the probability. So what is the probability that I get a blue on the draw? Well, again, what I do is I put the total number in my denominator, and then I look for the number of ways that I could draw a blue ball. Well, there's just 3 in there, so that 3 is my numerator. That or, remember when we're talking probability, from our probability rules lecture, tells me that I should add. So I'm going to add my probabilities. That or lets me know I'm going to be adding. Then I'm going to look for the probability that I get a black. And again, my total number goes on bottom. And then I look to see how many blacks there are in the urn. There are 4 there. Remember with or, we should always look for any overlap. to make sure, and then we have to subtract off that overlap. But in this case, blues and blacks don't have any overlap. So we're simply just adding. We add this together, add your numerator, and keep your denominator. So the probability we get a blue and a black, a blue or a black in one draw is 7 out of 10 times. So if we drew 10 different balls, we would expect to get a blue or a black 7 of those times. All right, let's do one more with one draw. And let's make this, instead of a blue or a black, let's say, what's the probability we draw a blue and then a black? So I want to know that probability. Now I'm going to draw one ball out. If I'm going to draw a blue and then a black, I would have to draw a blue and then a black. But how many balls would I end up with then? I would have 2, not 1. So it's not possible for me to get a blue and then a black with just one draw. I just can't do that. So when you're doing probability, you have to think first about the situation before you start putting numbers down. So in this case, the probability that I get a blue and then a black is 0 because I'm just drawing one marble out of the urn. All right, let's switch it up a little bit. Instead now, let's draw 2 marbles from the urn. And let's say that when we draw them, we draw one, look at it, and then put it back, and then draw another one. So we're going to call that with replacement. In other words, we're going to take it out, look at it, and then put it back in. And I want to know what's the probability that on the first one, let's do the same problem. That we're drawing two balls. What's the probability I get a blue and then a black? Well, if I'm drawing from the urn, in order to get a blue and then a black, I would have to first draw the blue. Again, I'm going to write down my words first and then worry about numbers. So I'd have to draw blue. I put the blue back in. Then on the second draw, so after I've drawn a blue, and on my second draw, I'm going to draw a black. And that's the only way, the only order I can go in to get a blue and then a black. So now that I have it written down in words, now I can find that probability and look at the probability of each. So the probability I get a blue on my first draw, well again, it's 3 out of 10. The and in here tells me, or remember from our probability rules lecture, that and tells us to multiply, that we're going to multiply our probabilities there. Now I've put the blue back in, so I still have 10 in there. And the probability I get a black on the second one then is 4 out of 10. Now anytime we're multiplying, I like to simplify before I make it big. So I'm going to simplify if I can. So the 3/10 can't be simplified, but this 4/10 is the same as 2/5. So I'm just going to simplify that down to 2/5, and now I'm going to multiply that out to make it, oh wait a minute, notice here, there's a 2 on top. When I multiply fractions, I just multiply straight across. Well, there's a 2 on top here and a 10 on bottom there. So they both have a factor of 2. So 2 goes into 10 5 times. And so on top, I'm just left with 3 times 1, which is 3, and 5 times 5, which is 25. There it is in its simplest form. The probability that I get a blue and then a black is 3 out of 25 times. So if I were to draw 2 marbles with replacement, 3 of 25 times, if I did that experiment 3 times, 25 trials there, I would expect 3 of the times for me to get a blue and then a black. All right, Now, I'm just going to take out one word from this problem. Instead of saying blue and then black, I'm just going to make it blue and black. This time it's in no particular order. So I could get a blue and then a black. Or, so again, I'm going to really encourage you to use words first and think about the different ways that you can do it. Wrap your mind around what the problem's asking first and write it down in words first. So we have a blue and a black. That's one way we could do it. Or we could get the black first and then the blue, and we would still have a blue and a black. So when I don't have an order that matters, when it's not necessarily in any specific order, I have to think about the different ways I could do it. So a blue and a black, or a black and a blue. And we're going to do the probability of that. Well, we just did the probability of blue and black. We found this was 3/10 and that was 4/10. Remember that the or tells me to add. Then a black and a blue, well, the probability I get a black is 4/10. And tells me to multiply. And then the probability I get a blue is 3/10. Now, when we are multiplying, I like to simplify. But anytime we're going to add, we are going to need to have common denominators in the end. So maybe we should just wait to simplify until the very end when we're having to add, because we'll want common denominators when we add. So I'm just going to go ahead and multiply. This is 12 out of 100 plus 12 out of 100, because remember, you just multiply straight across. So 3 times 4 is 12 and 10 times 10 is 100. And now I'm going to add the two fractions. So when I add fractions, I keep my denominator and add my numerators. And I'm going to go ahead and simplify now. 4 goes into both 24 and into 100. So I'm going to divide by a fancy 1 there. Divide by 4 over 4. And we get 6 out of 25. So I would expect, if I did this 25 times, 6 of them to be a blue and black in no particular order. Okay, let's do one more where we draw 2 with replacement. Let's this time draw 2 of the same color. Draw 2 of the same color. And again, the first thing we want to do is put down words. And then we can worry about putting down numbers. But first, let's just get our minds wrapped around how we could draw 2 marbles that are the same color. So I'm going to draw 2 of the same color. Well, one color could be blue. And if I draw blue on the first one, in order for me to get 2 of the same color, then I'd have to get a blue on the second one. Notice I use that word blue, and, because I have to get a blue and a blue. Or, maybe I don't get a blue on the first one. Maybe I get a red on the first one. So another way to get 2 of the same color would be to get a red and a red. Or, instead of getting a blue or a red, maybe I get a black. In which case, I would get a black and a black. And there are just 3 colors, so therefore there's just 3 different ways for me to do this particular probability. So again, putting it in words is really helpful and really important to do first. Once you have it in words, it makes finding the probability so much easier. So now I can find the probability of each. Well, I'm going to put, the probability I get a blue on the first one is 3 out of 10. And tells me to multiply. I put the blue back in, so I still have 3 blues in there and 10 total. So my probability is still 3 out of 10. Or, The probability I get a red is again 3 out of 10. And I put that first one back in, so I still have 3 out of 10 in there. Or tells me to add. The black, there are 4 out of 10. I put it back in. The and, multiply, put it back in, and the probability I get a black on the second one is still 4 out of 10. Now, again, I'm going to have to add with the fractions, and anytime I'm adding fractions, I'm going to have a common denominator. So I'm going to wait to simplify until the very end, anytime I'm adding. So I'm just going to multiply each one. So 3 times 3 is 9. 10 times 10 is 100. Plus 3 times 3 is 9. 10 times 10 is 100. Plus 4 times 4 is 16. 10 times 10 is 100. Now I'm going to add those together. So remember, you keep your denominator. Add the top. So 9 plus 9 is 18. Plus another 16 is, what, 18 and 10 is 28. Plus 6 makes 34. So divide the top and the bottom by 2, and we get 17/50ths. So if we did this experiment 15 times, I would expect 15 different trials. I would expect 17 of those to have the same, 2 of the same color. All right, let's change it just a little bit. And now let's make it, instead of with replacement, let's say without replacement. So now I'm just going to do the exact same problem, but let's do it without replacement and see how that changes things. I still, though, want to find the probability that we get 2 of the same color. Oh, well, we've already done the words. That's the first thing we want to do each time, is write it down as words. And we've done that. We could get a blue and a blue, or a red and a red, or a black and a black. So changing it to without replacement did not change my words. Let's look to see if it changes the probabilities. So the probability I get a blue on the first draw is still 3 out of 10. But now I'm not going to replace it. I have this blue in my hand. Notice there are now only 9 total balls in the urn. That 9 is my denominator. And there are 2 blue balls. So that's now my numerator. The and tells me to multiply. I'm now going to add. When I look at getting a red on the first draw, well, there's 3 out of 10. But that same situation where I have this red in my hand, that means I only have 9 total balls in the urn. And there are now only 2 red ones. The and means multiply, the or is add. I look to find the probability of a black on the first one. Well, there are 4 out of 10. But once I have a black one out of the urn, then that means that there are now only 3 out of 9 there in the urn. And I'm going to go ahead and do this. Again, because I'm adding, I'm going to wait to simplify until the very end. I'm going to want a common denominator in order to add. So 3 times 2 is 6. 10 times 9 is 90. 3 times 2 is 6. 10 times 9 is 90. And this is 12 90ths. Add those together. I've got 12 plus 12, which is 24 90ths. I can go ahead and divide the top and the bottom by 6. So 6 goes into 24 4 times, and 6 goes into 90 15 times. So if I did this experiment where I drew 2 without replacement 15 different times, 4 of those times I would expect to get 2 of the same color. Let's change this and make it just a little more difficult by drawing 3 marbles. So now let's draw 3 out of the urn. And let's get 3 of the same color. So there are several ways we could do this. Actually, instead of doing that one, let's do this. Let's draw a blue. Let's get one blue, black, and a red. I want to know what's the probability that I get a blue, a black, and a red. Okay, again, before you start putting down numbers, it's really important to get your mind wrapped around what it is that we're doing and write it down with words. So I'm going to do that first. I'm just going to think about the different ways I could draw 3 balls, a blue, a black, and a red. So drawing out the balls, I could draw a blue on the first one, and a black on the second one, and a red on the third one. But this question does not tell me that I'm supposed to do a blue and then a black and then a red. So it can be done in any particular order. I can pull out 3 balls without replacement and have those 3 balls, a blue, a black, and a red. And I wouldn't have to get them in that order. So I could do it this way. I could get the, maybe I get the blue first again, but then I get the red second, and the black last. That's another way that I could have the same situation happen. Or maybe I don't get the blue first. Maybe instead I get the red one first. Let's move that down just a little bit. So if I get the red one first, then I could get the blue one next, and then the black one. So another way to get this same situation is to draw a red and a blue and a black. Notice these conjunctions in here, or and. They really help us when we are finding the probability. But the first thing we want to do is figure out all those different ways to draw what the problem tells me to. So here I've got this, but I could do this. I could get red first and then get the black and then blue. So red and black and blue. But that's not all, because I could also get the black first, and then get the blue, and then get the red. Or I could get the black first, and then the red, and then the blue. I think finally I've gotten down all the different ways to do it. Now I can check to make sure this is all the different ways, because I have 3 options on the first one, so 3. Once I've decided on a color from there, now I only have 2 colors left to choose from. So from our counting, we can say 3 on the first one times 2 on the second one times 1 choice on the third one. How many different ways are there? Well, there are a total of 6 different ways in order to draw these 3 colors. 6 different arrangements for it. And sure enough, we have 1, 2, 3, 4, 5, 6 different arrangements for it. So now that I have it down in words, now I can finally put my probability with it. But first you want to come up with all your different words first. Now it's easy. The probability of blue is still 3 out of 10. Now I have the blue in my hand, so I only have 9 left. And there are 4 blacks. And I have the blue and the black in my hand, so now I'm down to 8. And there are 3 reds. That or tells me to add. The blues, still 3 out of 10. I've taken one out, so I'm down to 9, still 3. The and tells me to multiply each time. And the blacks, I'm now down to 8, but I have 4 in there. I'm going to put in the probability for each one of these, remembering that the ors tell me to add and the multiplication, the ands tell me to multiply. I'm also remembering to count down because I'm taking one out each time. And then just counting to see how many of each color ball there are. And the ors tell me to add, while the ands tell me to multiply. Now it's just a matter of doing the arithmetic. 4 out of 10, 3 out of 9, and 3 out of 8. So do a little, oh, notice something. Notice how on top, for all 6 choices, I have the same numbers. I have 3 times 4 times 3. This is the same thing, it's just in a different order. So, 3 times 4 is 12, times 3 is 36. 3 times 3 is 9, times 4 is also 36. No matter what order they're in, that top part is going to be 36. So all of them have a top part of 36. On bottom, there's 10 times 9 times 8 on every single one of them. So 10 times 9 times 8 is 90, times 8 is 720. Instead of adding 36 over 720 6 times, I could just take that and multiply it times 6, because there are 6 of them, to find that out. Now, I could do a little bit of simplification here. 6 goes into 720. Well, it goes into 7 one time with 1 left over. It goes into 12 2 times with 0 left over, and then it goes into 0 0 times. So when I multiply 6 times 36 over 720, I get 36 over 120. I can divide the top and bottom, well, by 12 over 12, a fancy 1 there, 12 over 12. 12 goes into 36 3 times, and 12 goes into 120 10 times. So it turns out that the probability that I get a blue and a black and a red in 3 draws without replacement is going to be 3 out of every 10 trials, or we would expect it to be 3 out of 10 trials. Okay, big deal when we're dealing with the classical or theoretical probability is first thing we want to do is write down the words. Once we have the words written down, then you can add the probability to it. Thanks for watching.